Hello students, today we will learn about cooling systems in the automobile. So all the heat produced by the combustion of the fuel in the engine cylinder is not converted into useful power at the crankshaft. So its typical distribution for the fuel energy is as follows. So here all the heat which is produced by the combustion of the fuel, when the fuel is burnt or combustion of the fuel takes place, then heat will be generated in the engine cylinder. So all this heat will not be converted into useful power at the crankshaft. So what happens to the heat? We will see here. So all the heat produced by the combustion of fuel in the engine cylinder is not converted into useful power at the crankshaft. So the distribution of fuel energy is as follows. So useful work at the crankshaft is 25%. So the energy which is used for work at the crankshaft is 25%. 25%. Then loss to the cylinder walls. So the energy which is lost to the cylinder walls is 30%. Then loss in exhaust gases is 35%. Then loss in friction is 10%. The quantity of heat given to the cylinder walls is considerable. So here we can see the quantity of heat or energy which is lost to the cylinder walls is 30%, which is a big number. And if this heat is not removed from the cylinder, then it will result in the pre-ignition of the charge. So what happens if this heat which is present at the cylinder walls is not removed from the cylinder? Then it will cause pre-ignition, that is, it will again ignite the charge which is present in the inside the cylinder, and excessive heating will also damage the cylinder material. So the cylinder material may also get damaged because of this excessive heating. So that is why the excessive heat must be removed, and this will cause a need for cooling system in the automobiles. So the quantity of heat given to the cylinder walls is considerable, and if this heat is not removed from the cylinder, it would result in the pre-ignition of the charge. And also excessive heating or excessive heat will also damage the cylinder walls. So this arises a need for cooling system in the automobiles. So there are two methods used for cooling of automobile engines. So cooling system is required in the automobile engines. So the methods used for cooling of automobile engines are, so the first one is the air cooling, the second one is the water cooling system. So now we will discuss about the air cooling system. Air cooling system. So the basic principle of this method is to have a current of air flowing continuously over the heated metal surface from where the heat has to be removed. So if this is the surface of the cylinder which has to be cooled. So this air cooling system works on the principle that a current of air is continuously flowing over the heated metal surface. So if this is the heated surface, the air must continuously flow on this heated surface so that the heat will be removed from this surface. So this is the principle of this air cooling system. The basic principle of this method is to have current of air flowing continuously over the heated metal surface from where the heat is to be removed. So the heat dissipation or the heat dissipates upon the following factors. So depending upon these factors, the heat will be dissipated from the surface of the metal. So factors affecting the heat dissipation. So what are they? The first factor is the surface area of the metal in contact with the air. So the surface area which is in contact with the air will be cooled soon, or the heat from that surface area will be removed faster. Of metal into contact with air. The second factor that is affecting is the mass flow rate of air. So how much air is flowing inside the or flowing onto the heated surface. Then the temperature difference between the heated surface and the air. So if the temperature difference is more, that is the air is cooler, then the heat will be removed faster. Then the fourth factor is the conductivity of the material, of the metal. So all these factors will affect the cooling or heat dissipation of the air. So the effective cooling, the surface area of the metal which is in contact with the air should be increased. So the cooling of the surface area of the metal which is in contact with the air should be increased. That is, the cooling must be effective. So how is that possible? The effective cooling the surface area of metal which is in contact with air should be increased. So this is done by using fins over the cylinder barrels. So fins are used on the cylinder barrels. So these fins, so here we can see that this is not pins, it is fins. So you can see these parts are the fins which are formed on the outer surface of the cylinder. So all these points which I am marking now are fins. So these fins are formed for effective cooling of the cylinder surface. So if this is the cylinder, the fins are formed on the outer surface of the cylinder. So these fins are either cast as an integral part of the cylinder. So while making the cylinder itself, you can make the fins along with the cylinder as an integral part, or they can be separately finned barrels. So this part, all the part which is marked with lines, this part is the finned barrel which may be inserted over the cylinder barrel. So if this is the cylinder barrel, these finned barrels can be inserted separately over the cylinder barrel. Sometimes, particularly in case of aero engines, the fins are machined from forged cylinder blanks. So fins are used on the cylinder barrels. These fins are either cast as an integral part of the cylinder or separate finned barrels are inserted over the cylinder barrels. In cases of aero engines, fins are machined from the forged cylinder blanks. So, use of copper and steel alloys has also been made to improve heat transfer because of their better thermal conductivity. So, copper and steel alloys are being used for making the fin barrels for because they have better thermal conductivity and they can dissipate the heat, or the heat transfer will be improved. So use of copper and steel alloys has been made to improve heat transfer because of their better thermal conductivity. So in order to improve the cooling system, baffles are provided on the fins. So here you can see there is a baffle here. This is a normal baffle. This is a complete baffle. So on both the ends a baffle is provided, and this is a short baffle. So what is the purpose of providing this baffle? So baffle or baffle plates. So in order to improve the cooling system of an engine, baffle plates are provided. So in air-cooled engine, the cooling air flows towards the cylinder surface at the front in an airstream. So however, it separates from the cylinder at the rear, reducing the cooling effect of the air stream on the rear of the cylinder. So if this is the cylinder or cylinder barrel, you can see air is flowing towards this surface. So this is the front surface of the cylinder. So this surface will get cooled easily. But what about this surface? How it has to be cooled? That is the rear surface of the cylinder. So in order to improve the flow of air to the rear of the cylinder, baffle plates are mounted on the outside of the cylinder or between the fins symmetrically with respect to the plane through the axis of the cylinder. So what is done is, in order to improve the cooling of the rear of this cylinder, so the rear end of the cylinder, they are providing baffles, or these baffles may be provided on the cylinder surface, or they can be provided in between the fins, which I have already shown. So the temperature on the fin surface, that is when the baffle plates are provided on the cylinder cooling, the airflow between the fins is with a high speed, and it results that with the baffle plates mounted on the outside of the cylinder, they have more uniform temperature along the circumference of the cylinder. So that is why, so when baffle plates are provided, the temperature on the surface of the cylinder is found to be uniform. That is, almost equal temperature was found on the front end where the air is flowing continuously, and also on the rear end where the baffles are provided. So they not only provide uniform temperature in the circumference, but also a greater average surface heat transfer coefficient was found. So that is why baffle plates of different types are being installed, so that the temperature will be uniform throughout the circumference of the cylinder. In an air cooling system, the cooling air follows the cylinder surface at the front in an airstream, but it separates from the cylinder at the rear, reducing the cooling effect of air stream on the rear of the cylinder. So baffle plates are mounted on the outside of the cylinder or between fins to make the temperature throughout the circumference of the cylinder uniform. So baffle plates, not only they make the temperature on the cylinder surface uniform, but also they have also provide average heat transfer coefficient. So this is how the air cooling system is working. So this is all about the air cooling system. Next we will discuss about the water cooling system. This type of cooling system is water cooling system. So we have discussed about air cooling system. Now we are going to discuss about water cooling system. So in water cooling system, the cooling medium used is water. So that is why it is called as water cooling system. The cooling medium used is water. So in this system, the engine cylinders are surrounded by water jackets through which the cooling water flows. So if this is the cylinder, it will be surrounded by water jackets in which the water will be flowing and heat will be removed from the cylinder walls and it will go into the water. This water will go to the radiator where it will lose its heat to the air. So in this system, the engine cylinders are surrounded by water jackets through which the cooling water flows. So as I have shown you, so if this is the water jacket, this is the cylinder, this is the water jacket. Through this water jacket, the cooling water will flow. So heat will flow from the cylinder walls into the water, and then the water that is carrying the heat goes to the radiator where it loses its heat to the air. So what happens after the water flow which is flowing inside the water jacket collects all the heat from the cylinder, it will be passed to the radiator. So if this is the radiator, the cooling water after collecting the heat from the cylinder flows into the radiator, and in this radiator it will lose all the heat, that is the water will lose all the heat to the air which is present. So there are mainly two types of water cooling system. So types of water cooling systems. So what are they? The first one is the Thermosymphone system. Second one is the pump circulation system. So the first one, that is the Thermosymphone system. So this is a very simple system which was used in many early automobiles up to 1940s. So this kind of system was used from the early automobiles up to 1940s. So simple system used in. So this system, that is the Thermosymphone system, is obsolete now, that is, it is not being used. Thermosymphone system. So this system consists of a radiator connected to the engine through flexible hoses. So this system consists of a radiator. So here you can see there is a radiator, and this radiator is connected to the engine through hose pipe. So here you can see there is a hose pipe here in the figure. So in this system, circulation of water is obtained from the difference in densities of hot and the cold regions of cooling water. So how the water is circulated in this system? So circulation of water depends on the density of hot and cool regions of the cooling water. So this system consists of a radiator connected to the engine through hose pipes. So circulation of water is obtained by the difference between densities of hot and cold regions of cooling water. The circulating water gets heat from the engine cylinders. Due to this, cooling is done. So the circulating water will collect the heat from the engine cylinders. Due to this, water gets heat from the engine cylinder, and due to this the cooling is done. That is, the heat is carried from the water in the cylinder. Then this heat in the water is dissipated into the atmosphere through the radiator. So when the water which has collected heat from the engine will flow into the radiator, then this heat will be dissipated to the atmosphere through radiator by convection and conduction. So when the water reaches the collector tank, so after it flows through the radiator and it is cooled, again it is collected in the collector tank. So when it reaches the collector tank, the water will become cool again. The circulating water becomes cold by the time it reaches the collector tank of the radiator. So the same water, that is the water which is collected in the collector tank, is again circulated through the engine to collect the heat from the cylinder. The same water is then circulated through the engine to collect heat from the cylinder. The rate at which the water is flowing or circulating in the system is proportional to the heat output or the load on the engine and not on the engine speed. So the water is flowing inside the cylinder, that we have seen. So here there are engine cylinders. Okay, the water is flowing through these cylinders and collecting the heat. So the rate at which the water is flowing is proportional to the heat output or the heat output from the engine. So whatever heat is coming out of the engines, and also the load on the engine, but not on the speed of the engine. The rate at which the water circulates in this system is proportional to the heat output or the load on the engine, and not to the engine speed. So some of these thermosymphone systems also have fans mounted behind the radiator and driven by belt and pulleys from the cranks to assist the flow of cooling air. So some of the systems, they also had fans which are fitted. So here you can see there is a fan which is fitted behind the radiator, and this fan was driven by a pulley and belt from the crankshaft so as to assist the flow of cooling air. Some of these systems also had fans mounted behind the radiator and driven by belt and pulleys from the crankshaft to assist the flow of cooling air. So the advantage of this system is they are very simple and cost is less. So advantage of this system is its simplicity, that is, it is very simple, and low initial cost. Now what are the disadvantages of this system? So disadvantages of thermosymphone system. So as the circulation of coolant is maintained by natural convention only, the cooling is rather slow. Therefore, to have adequate cooling, the capacity of the system must be large. So as the circulation of the coolant is maintained by natural convection only, the cooling of this system is slow. As the circulation of coolant is maintained by natural convention only, the cooling is slow. Then, due to the quality of the coolant being large, it takes more time for the engine to reach the operating temperature. So due to quality of the coolant being large, it takes more time for the engine to reach the operating temperature. Radiator header tank must be located higher than the top of the cylinder coolant jackets, which is not possible with modern body styles. So the radiators must be kept higher than the cylinder coolant jackets. So which is not possible with the modern body styles of the automobiles. So this is about the cooling system, that is water cooling system with the help of thermosymphone system. The next type of system is the pump circulation system. So this system is same as that of thermosymphone system. The only difference is that a pump is used for circulation of coolant and a thermostat is employed to control the flow of coolant. So here you can see there is a thermostat and there is a pump here. So these are the two extra components which are added to the thermosymphone system. So pump is used to pump the coolant or for circulation of the coolant, and a thermostat is employed to control the flow of the coolant. So in thermosymphone cooling system we had seen that there was no pump and the coolant was just flowing inside this system by natural convection, and that is why we saw that the cooling process was very slow. That is why they have made a modification and used a pump for circulating the coolant into the system. This system is similar to thermosymphone system. The only difference is that a pump is used for circulation of coolant, and a thermostat is employed to control the flow of coolant. So how this pump is driven? The pump is driven through a belt or by means of a belt from the engine's crankshaft. The pump is driven by means of belt from the engine crankshaft. So the fan which is present here behind the radiator is also driven by the same belt that drives the pump and the generator. The fan is also driven by the same belt that drives the pump and the generator. So this system, that is the pump circulation system, also has the same process. So the water flows through the cylinders of the engine, it will collect the heat and then it will be pumped into the radiator with the help of this pump, and then what happens is there is a fan here which will rotate and it will cool the water which is passing through this radiator, and there is a collector tank here where the water is collected, and you can see in this system thermostat is used for controlling the flow of the coolant or the water. So why it is called as coolant? Because some antifreeze is added to the cooling water. So that is why sometimes we refer to this cooling water as coolant. So some antifreeze is added to the water, and hence we refer to it as coolant. Okay, so this is all about the water cooling system. So I hope you have understood what is water cooling system, types of water cooling system, what is thermosymphone water cooling system, and what are the advantages of this thermosymphone cooling system and what are the disadvantages, and how the thermosymphone cooling system was modified and made as pump circulation system to remove its disadvantages. So the second type of system is the pump circulation system, that is the modification of thermosymphone system. So I hope you have understood the topic. Thank you.